Hello, my name is Charles Wade. I'm a PhD student in the Matter Assembly Computation Lab at the University of Colorado Boulder. Today I'm going to be kind of continuing a series of videos on how to use OpenVCAD and how to get started with it. So this is just a sort of quick example I wanted to show about how constructive solid geometry works within OpenVCAD and how we can create objects with different materials using that. So if we go ahead and go to File, Open, and then we go to Examples, and then Basic, we're going to go to CSG Mug. So if we open this up, we're going to see a whole VCAD design in here with lots of different child components. So if we go ahead and open this up, and we're going to render, we'll render with voxels, and we can look at the mug and kind of get an idea of what's going on here. We've got a cylinder, we've got this kind of torus over here. How exactly do we make this object? So if we look through it here, right, I've left comments at different areas that explain how we're constructing this object. Like most VCAD things, I find it most helpful to kind of work in section and look for the comments and work outside in. So if we're looking, here we've got kind of the handle plus the cup outside. We've got comments here for the cup outside, the handle, and the inside of the cup, right? One of the ways that we can kind of hack around and see what's going on here is to actually, go through and, delete different parts of this, right? So like, let's say I want to know what it looks like without, the cup outside, right? I can delete that, re-render, and now we just have that handle left behind, right? So specifically what's going on in this design is we've defined a couple of different things. In the case of the cup itself, right, we're using functional geometry, so x squared plus y squared minus some radius squared is going to be the equation of a cylinder, right? And specifically a cylinder that extends infinitely, from top to bottom, right? So vertically, since we have no z component, this is going to be everywhere vertically. We define this with a blue material. The problem with that is we really want this cup to be bounded by something, right? I mean, it's going to need to have a bottom. So to do that, what we're doing here is creating a rect prism that's a little bit bigger than whatever we want, right? So this is essentially a bounding box, and I'm taking the intersection of these two. Right, so by taking the intersection, it's going to basically chop off our cylinder at the actual volume that we want, right? So that's the outside of the cup, right? The inside of the cup uses a very similar setup. We're doing that same thing. This intersection down here is the same code as up here for the outside. The only thing we're doing is scaling it back a little bit, right? So we're leaving the same z-scale, but we're making it 75% smaller in each one of these axes. Right, so if I wanted to make the cup have thinner walls, we could take this up to like 0.9. Go ahead and render that, and now you can see we have thin walls, or perhaps we could have had the opposite. It had really thick walls. So I'll set that back. You can see the parametric nature of OpenVCAD is really great. You can just rapidly prototype just by changing small values, very similar to what you can do in OpenVCAD. Now, let's talk about the handle. The handle is defined with what we would probably call a half torus, right? It's really this torus kind of chopped in half on the outside. So that's exactly what you see right here. So we have this function right here, which is the equation of a torus. I just pulled this offline, but it is a function of x, y, and z. Specifically, I defined this around the z-axis, so I actually ended up rotating this by 90 degrees to get it to the axis that I needed to stand it up vertically. As well as I scaled it back a little bit. It was a little bit bigger than I wanted. I could have tweaked the parameters down here in this equation to also change the scale, but it was easier to just apply a scale node on top of that. And then finally I translated it into the correct position. Now notice that we had the inside and the outside of the cup kind of separated differently, and the handle, right? Well, that's because, without this, right, if we just had the torus, this cup, we would have the torus extending through the inside of the cup. So what we're doing here, right, is we've defined, our cup outside, our handle, right, and then we actually take the union of that, right? So we union these two objects together, and then finally we go ahead and we take the difference of our whole cup, including this completely filled in, right? So if we deleted all of this, we would have a filled in cup with just this torus kind of sticking through it, and we subtract everything from it, right? We subtract all of that inside out, and that gives us this nice object. We do make sure that when we subtract out the inside that we have, made sure that we translate it up by 0.25 to make sure that our cup doesn't have a hole in the bottom. So if I set this to 0 and I tried to design this cup, we would have a hole in the bottom, and we don't want that. So one last thing to note here is the hierarchy of kind of the materials we defined, right? We defined all of our cup materials in blue, our handle in green. We could change, this to be cyan if we wanted. Go ahead and re-render. Our cup handle would now be cyan. If we wanted to create some kind of gradient across this whole cup, or maybe just across the handle, we could apply different nodes. All we would have to do is add it to this tree structure.